Hello, welcome to Tech Talks. Our platform edition today is focused on Splunk Machine Learning. Tech Talks is a series of short webinars focused on features and best practices within use cases. We value you, our customer, and want you to continue in your Splunk journey. Our experts help create these tips and tricks, and we want you to leverage them in your daily role. I'm Jessica Davlin, a Senior Product Marketing Manager for the Splunk platform focused on machine learning. I'm excited to be here today to share with you information about what's possible with the latest release of Splunk's Machine Learning Toolkit, or MLTK for short. The Splunk Machine Learning Toolkit app delivers the capability to operationalize machine learning models on your data in Splunk and is available with any Splunk Enterprise or Splunk Cloud license. I'd also like to introduce you to my colleague, Ganendra Rana.
Hey all, I'm Ganendra Rana, Product Manager for AI and ML and working in Splunk from the last 5 years.
Ganendra will be going into more depth as well as showing you a demo later in this Tech Talk. So let's briefly cover off on the agenda. Today, we are going to talk about a few things, including experimenting and modeling your Splunk data using machine learning tools. We'll also talk about what is possible with Splunk's machine learning capabilities. We'll then walk through a great demo of the Splunk Machine Learning Toolkit with a couple of different use cases highlighted. And then finally, we will cover additional resources available to help you take advantage of machine learning in Splunk. Our team will be available for Q&A throughout this Tech Talk using the chat feature. If you are watching a recording version of this webinar, please continue the conversation through the Splunk community website for any follow-up questions. So let's dive in. Many organizations are already tracking and monitoring their event and metric data using Splunk. But did you know that Splunk offers the ability to experiment and model data with machine learning for your IT, security, and DevOps use cases? Machine learning can help you derive more insights from this data so you can ultimately make faster, more informed decisions. Furthermore, our smart assistants can guide you with experimentation so you can build different models to help you forecast events and detect anomalies. As mentioned, machine learning can help you leverage your existing Splunk data to do even more. We like to think about using data you already collect to help you with three possible scenarios. First, outlier and anomaly detection. This may include deviating behaviors or unusual changes you might observe. Second, predictive analytics, to include things like forecasting and predicting events, or spikes in behavior, or possibly early warnings of failure in the context of predictive maintenance. And third, data clustering, to correlate events or reduce the noise of alerts by grouping them together. Our demo today will cover both outlier detection and forecasting. But before we talk more tactically about building these models in Splunk, you may hear the different terms when it comes to machine learning, unsupervised and supervised. Building supervised versus unsupervised machine learning models essentially breaks down into whether the data set you are using to train your model has a matched set of questions and answers that you can use to learn a relationship and propose potential outcomes to new questions. Supervised data would include labeled or matched data, whereas unsupervised would be a one-sided set of data that could be analyzed to determine similarities, which would be recognized in future data inputs. I will now turn it over to my colleague to talk about building a model and showing you a demo of MLTK.
Thanks, Jessica. Today I'm going to give a demo on Splunk Machine Learning Toolkit with its new features on Smart Assistant and showcase examples. But before I move to demo, I would like to talk about machine learning workflow. That is, how do you build your model? The first thing is to determine the goal of your work, the problem you want to solve using machine learning. Once that's clear, explore the relevant data and clean the data you don't want to use for building models. This is the most important step in the machine learning workflow. Once you are done with data cleaning, apply the algorithm, evaluate your result as per your use case, and deploy the model into production. This should be a continuous process as the model needs to be retrained with the new data coming into the system. In the last slide, I was talking about machine learning workflow, and new Smart Assistant is designed around this workflow. Each workflow step has its own place and it demands less configuration. The Smart Assistant guides you through the steps of building a model, and as the models are trained, you can put them into production through an easy-to-use, customizable interface. This simplified workflow aims to remove complexities associated with machine learning exploration. It has step-by-step workflow for ML outcomes. It gives guidance through the steps from a point-and-click setup, has interactive customization and visualizations, and clear summary of the use case. Let's jump to the demo. In the demo today, I'm going to present two use cases on forecasting and outlier detection.
Hey, let's demo with a couple of use cases. The first use cases which I'm going to show here is on smart forecasting, and then we'll move to the smart outlier detection. Now, for the first use case, it's about an e-commerce platform wants to check the count of login to its application and forecast the number for next 30, 60 or 90 days. The goal here is to make sure the system has enough resources for the days where there will be higher number of users logging to their system. So for this case, I come to the ML toolkit, open the Smart Forecast Assistant and create a new experiment. It brings me to the page where you can define the data. Now in my case, I'm going to define the data using search, but you can also define the data using the data sets and metrics. As a user, I want to see my data first before moving to the next stage. So I can see my data is from April 2018 to January 2019. Once done, I will move to the next stage. In this stage, I want to forecast the logons, which is basically the count of logins per day. But wait a second. What about special days? The days about the bank holidays, the Black Friday sales, or the other sales launched by the company itself. So for that case, what I will do is I'll create a lookup file which has all those dates mentioned, as you can see from here. And now I'll take this lookup file and join it here. I give my lookup file name, time field in the data, time field in the lookup, and add field from the lookup. In my case, I want to add the holiday value and the holiday name. Once done, I can click on join. Now you can see it has joined the days, the special days, and now I'm ready to forecast. Now I'll select the logons. I'll give 0 as the holdback period. You can see the tooltip, which actually tells me what it is for. Basically, it's for validating the model. And going back to my use case was forecasting for the next 30 days. I'll take this as an option and click on forecast. This takes a couple of seconds based on the data. Now you see a warning message here. this message is telling me there were some null values within the data, and the algorithm itself impute them. That is, you don't need to make them continuous. The algorithm is powerful enough to do it. Now we have the data. Now the thing which you see over here is the SPL. Now this whole thing has been built by the Smart Forecasting Assistant. Now I move on to the next stage and review my stats. In this stage, you can see the R-square value and the RMSE values. Now, I also want to see, instead of mouse hovering to my forecast, I want to see what is my forecasted value at certain day. It says no data available. I'll move to other day. And now I can see that the forecast for that day was 143.63. Now, my use case, one of my main points of the use case is when it's going to violate the threshold. So imagine a situation where I want to see when my logons would be greater than 100 a day. So now in this case, it clearly says there will be a violation in one day, and you can actually review it and act on it. Now, as a user, I have got the days, the forecasted value, and the RMSE. So what next? I'll save it. I'll move to the next stage. And now I have an option to operationalize my model, which is basically the outcome. So I have the 30 days of the data. If you go back to the use case, I have the 30 days of forecasting. And now what I'll do is basically I'll create some alert. And then I'll also add the machine learning conditions. If the value of the logons is greater than 100, just alert me. Now, once this is done, as the new data is coming in, I want to make sure that this always runs on the incoming data. So I schedule a model training, which will keep training my model as the new data comes in. This saves a lot of my time, and I'll always be getting an alert for any kind of overusage for the number of logins. Now we have done the smart forecasting. What's next? The other most popular examples which I have seen which people use is the outlier detection assistant. So let's take another use case where a system admin wants to find the outliers in the call volume at the call center coming through different sources. He wants to check the outlier by day of the week, like what's there from Monday to Sunday, and wants to see from which source we have the maximum outliers. For this purpose, I have already created an experiment. I'll walk you through it. So I check my data, and the data I can see it's a time, it's a count, and you can get different sources. Now, once I have seen my data, I'll move to the next stage. Just a note, I'm using the inbuilt data which comes with Splunk ML Toolkit. Now I can extract time. As I was talking about, I want to get the outliers by day of the week. So what I'll do is I'll run the extract time, which will basically get me the data. You can already see this data over here because I have already run this experiment once. But now it will show you the different data which you can extract, like by day of the week and the hour and everything and other stuff. As you can see from here, you get the hour of the day, day of the week, day of the month, and month of the year. Once done, you have already applied the extraction. Now let's go into the next stage where I want to analyze the count of calls coming in, and then I want to find the outliers by day of the week and different sources. You can also see the SPL which has built. So the smart outlier detection actually makes it very easy. Imagine writing everything by the SPL. Now we build the SPL, the entire thing has been built by the smart assistant. Now, an easy button, we click on the detect outliers. It will take some time. You can also look into the history stuff, which gives you a side-by-side comparison for the different times, for the number of times you have run the experiment. And you can load them by running the same model again. You can go back to the same model back. There it is. Now, it has been grouped with the top 3 different goes to the most outliers. You can actually have a combined view or the split view. And I want to see the outlier by the time. Now, to the time it loads, you see the total number of outliers which is coming as 22. Now I want to see where are these outliers coming from which group it is coming. So there are 22 outliers coming from the SGI source. There are 0 outliers from the active agents and from the call volumes. So now I have seen it, and now actually I can move to the next stage where I get the model summary, cardinality histogram, if I want to see that, distribution properties, and the outlier analysis. This is the most important step here for the outlier analysis, which you can see there were 9 outliers on Thursday, 6 outliers on Sunday, and 5 on Wednesday, and 1 respectively for Monday and Saturday. And all the outliers are coming from the SGI source. Now once done, we can move and we can just save it. So now we have done with the 2 most popular cases, and you have seen how it's easy doing through the smart assistant. If you want to look into similar use cases, you can look into our showcase examples. We have redesigned the showcase examples, and it is now easier to navigate with a modern and intuitive UI. With the new showcase, you can easily filter examples by ML operation, industry, or drill down to the example for a specific use case. Like in this case, you can go into the predict fields, look into the feature examples and the other examples. Similarly, you can go into the industry and you can see the number of examples it has. And for each of them, if you see, we have labeled them, whether it's an IT, whether it's for security and all this.
So let me summarize the things I have said so far. What ML can help with? Check the ML Toolkit showcase for inspiration. Where do I start? What are the steps? Use a smart assistant and move through the steps in order. How do I know if this is even working? Use Learn, Evaluate tab and review scoring metrics. How do I tweak things to make it work better? Explore different settings and use history to load the one that works best for you. Now that it's working, how do I make it go? Use the operationalize step. We have some great resources available for you to take over from here and start exploring Machine Learning Toolkit. Check out the documentation, blogs, and .conf presentation on machine learning use cases using Machine Learning Toolkit. And also, you can download the app on Splunk base. There will be a follow-up email with all the links. Thank you for listening. With that, I'm handing it over to Jessica to take this forward.
So as I mentioned before, whether you are joining us live today or watching this Tech Talk as a recording, please continue the conversation with us on our Splunk community website. We really appreciate you taking the time out of your busy schedules to join us today. Please tune back for future Tech Talks. We're excited to share this series with you. Thank you again.